which is looking about integrating ln. So A part 1 then, that actually gives us an awful lot of help by writing ln x, as ln x plus 1, use integration by parts. So by parts says we've got to choose a u value. Now remember we've got this acronym, which is LATE, which stands for logs, algebra, trig, exponentials, and that's the order that we pick our u value in. So in this case I've got a logarithm and I've got nominally an algebra term of 1 there. So I'm going to choose u to be ln x, and I'm going to choose dv dx to equal 1. Okay, so then du dx is the differential of ln x, which is 1 over x, and v is the integral of 1 with respect to x, which is x. Okay, so now we need to remember our integration by parts formula. So remember it is u dv dx equals u times v minus the integral of v du dx. Okay, that's in your formula book, so there's no need to try to remember that one. That's in the formula book ready for you. So now it's a case of just popping everything in and hoping things drop out okay. So I've got u times v, so that's x times ln x. I have just changed the order of those two things because we tend to write it like that instead of ln x times x, minus the integral of v, which is x, and quite conveniently times 1 over x, and we integrate with respect to x. So what we end up with is x ln x minus, now these two, this x here is cancelling with this x here, which leaves me with the integral of 1. So my final answer is x ln x minus, and then integral of 1 is x. And remember your plus c. Okay, this is a very, very picky mark scheme that only excuse me, that only gives you 3 out of 4 if you don't have your plus c. So I'm going to continue now with part 2. I'm just going to clear the board a little bit, but I am going to keep this this part, because the integral of ln x coming to that is really important for the next part of the question. Here we go then, we're back again, and only now we've just got our answer from A part 1 as well to help us with part 2. So with part 2, that will just disappear in a moment when I start typing. There we go. So for part 2 of this one, we need to find the integral of ln x all squared. Now there's lots of different things you could try here, but what we're expected to do is to write it as ln x times ln x. Lost an x there. So, and use by parts again. Okay, so I'm going to choose u to be ln x, and I'm going to choose dv dx to be ln x. I haven't got any choice in that matter. They're both logs, they're both exactly the same. So du by dx is going to be 1 over x, as it was in part A. But v, well, is the integral of ln x. Now fortunately we did that in part A, so we're just going to copy that down. Now I'm not going to copy down the plus c. Plus c will come in at the very end after everything's gone through. So now we need our integration by parts formula again. So that says that's u dv dx. So if I'm integrating u dv dx, that equals u times v minus the integral of v du dx. Okay, so now we're just going to put all what we've got into this part of our formula again. So u gets times by v, so I've got x ln x minus x all being times by ln x. Okay, not lovely, but it will do. And then I'm subtracting the integral of v times du dx. So x ln x minus x all being divided by x, and that's integrated with respect to x. So let's tidy up this left hand side a little bit. I've now got x, ln x times ln x is going to be ln x squared, excuse me, minus x ln x. So that's that bit just tidied. I've expanded that bracket. Inside my integral here, everything, we've got the x on the bottom and the 2x on the top. So that x is cancelling with that x and cancelling with that x as well. So leaves me with the integral of ln x minus 1 dx. Okay, so from there, well, go back to the first part of the question. We already know how to integrate ln x. We certainly know how to integrate minus 1. So I've got x ln x all squared minus x ln x minus. Now we've got this thing here, so let's just make sure we get our minuses right. So pop it in a bracket, ln x minus x. And we're also, so that's ln x integrated, that's there. And if I integrate 1, I get x as well. So minus a second x. And my integration has been done. Let's finally bring in our plus c. So tidying this up then gives me x ln x, and that was squared. I've now got minus x ln x minus another x ln x. Okay, so that's minus 2x ln x. And this minus still distributes over these two. So I've ended up with the 2x's in there, minus 2x in there, minus outside, so plus 2x plus c. And there is our final answer and another 4 marks for that question.